Yeah, so any other questions? I think you've got it all right. Then.
No, sir, actually, some of us like had a doubt about that junction thing, but like we did know that normal Dijkstra is also working, so we were trying with the junction thing, but we couldn't understand what exactly it meant.
See, junction means that any node which is common between at least two paths, right?
Yes, sir.
So yeah, that's also, and then what you can do is you can consider the graph instead of having all nodes. You can consider the subgraph which is induced by the start node, the end node, and all junction nodes, basically. Because your junction nodes are sufficient to cover the overall connectivity.
Okay, sir, got it.
Anyway, but if it is running for the file, then it is fine.
Sir, after getting the junction nodes, what should we do?
Uh, what should you no? Basically, it is just to make things faster, So it is like, so you have to calculate the distance between the junction nodes. See, if you take all the nodes, then what do you have to do? You have to calculate the distance between each and every node, right? But if you are using the junction node, then you have to calculate the distance between the junction nodes. So that means you have to consider all paths from a given junction node, like to another junction node. If I mean, like, not all paths, but they are part of this same path or not. It has to be through one path only. Hmm. So then you consider and you calculate that distance. Okay, so this is the first step. So once you have distances between all junction nodes, then suppose somebody gives you uh, two different nodes that give me the distance between distance of the shortest path between nodes A and B. Okay, so you have to form a graph where you have the node A, the node B, and all the junction nodes. And you have to basically calculate the distance from node A to the nearest junction node and node B to the nearest junction node. Okay, and that also is very easy to compute because so node A, if node A and node B are junction nodes, then you are already done. If they are not junction nodes, that means they are only part of one path. And if that is the case, then you basically have to compute the distance from the nearest junction node in that path. That's all. Maybe,
Sir,
sorry, maybe both sides you have to calculate. Yes,
sir, there are 2,500 junctions.
2500. Yeah, so that was my thought also, that the number of junctions will be much less.
Sir, but with 2,500 junctions, uh, like, sir, how do we ensure that finding out the nearest junction would suffice? Because there might be a junction which goes in some, like, in the 90-degree direction, like from the nearest junctions, which will give a better solution.
No, because you are only calculating the distance through the path. Right. So if you are calculating distance through the path only, the crow flies distance, even if it is shorter, you will not consider that between any two nodes, basically.
Yes, sir,
Only,
but one node can be part of, let's say, six ways, and in each of these six ways, there are one junctions each. And let's say if we go to the junction which is the third closest, then it gives us the optimal solution.
No. So if one node is part of more than two or more ways, then it is already a junction.
Okay, sir. Yes, sir. So then we need to do Dijkstra on like considering the junctions only.
Yeah, so only situation where only nodes which you will need to include which are not junction nodes are the ones which are part of are the start and the end nodes. Suppose the start and the end nodes are not junction nodes, then what you have to do, you have to connect them to that means what? It is part of only one particular path or way. So that means you have to calculate it to at most the two nearest junction nodes in either direction in that particular way. Am I making sense?
Yes, sir. Yes, sir.
Right. Yeah, see, this is because of the nature of this OpenStreetMap data. It is basically what they do is they collect periodically the GPS location of the device. So there are a lot of nodes which are probably not important.
So in case 3, what is the importance of part 1?
In use case 3, you mean step 1?
Yes, sir.
Create an incidence data structure which stores whether ith way contains the jth node. Yeah, so this is basically the number of nodes times the number of ways data structure, right? So then the step 2 becomes easier if you have the incidence data structure, then step 2 becomes easier. I mean, without this, you cannot, without step 1, you cannot easily create step 2, right? Step 2, you have to calculate the distance between all the nodes which are connected by a path or a way, right? So if you don't have the incidence data structure, how are you going to connect nodes?
So actually, we need the latitude, longitude. So we have to use a map.
No, but you cannot collect all nodes with all other nodes.
So we can iterate through each ways and keep on connecting them. That's how the how the incidence data structure help if latitude, longitude data is not stored.
So you are saying keep passing through all ways and keep creating this. So that is the same thing. Actually, that is step 1 basically. Yeah. So you are going way by way, and then for that way you so you look up the node ID and then you get the latitude longitude from there. Right, that is what you are saying. So that is basically step 1. You are doing step 1 only.
But like in step 1, we actually need a map to ID maps to latitude, longitude data. Where map to, then it is not coming to use.
No, the node is mapping to latitude longitude data. So inside the node, you can store the latitude longitude data. Right? Am I Have I answered your question?
Like I'm not understanding if you can means that how will the data structure help in creating the graph?
Okay, so see, for the what is the data structure saying? So it is doing the same thing basically what you are saying, that if you take the ith way, okay, you find all the nodes which are connected to the ith way. Okay, so then you can connect all the nodes which are connected to the ith way through basically yeah, so you can basically connect them. Okay, uh, uh, and you can basically add the distance there. Otherwise, so that is what the step one is. But maybe yeah, so you can do in an online manner also, like just go through so okay. Let me put it this way. Oh, okay, sorry. Is it clear, or do I have to explain? Is it clear that I think we are saying the same thing? Okay.
Like is it compulsory to do it, create this data structure, or we can create the graph in any other way we want?
Okay, so is it compulsory? No, no, it is not compulsory, because you see, I have written here, you can follow the following steps. So this is kind of a hint. Okay.
Yes, sir.
Okay, any other questions?
Sir, one doubt, sir. If we find a node which is matching with the name that we have inputted, then what all details we need to print for that node? Just that we have found it, or anything else?
So the name, the node ID, latitude, longitude. See, every node has these things, no? ID, latitude, longitude. And because you are searching by name, so you will, or searching by part of the name, so you have to print the name.
Okay. Yes.
So in the use case one, do we also need to print all the nodes and all the page?
No, no, only the total number of nodes and total number of ways. And then when the user search by name, whatever nodes match that name, you print all of them. So many nodes may match that name, no?
Yes, sir.
Sir, you said about the junction method. So when I want to find the start and end are not junctions, so I need to find the closest junctions to the start or the end. So in that case, should I basically means I have to store all the edges as means as paths. So in that case, how will it help me in reducing the storage?
No, but your total number of nodes has reduced to something like 2300 plus 2. No. And the respective edges. So that will help reduce the storage, no? Am I clear?
Yes, sir.
So for the K closest, can you print only the ID?
Can you print only the ID? So I would say at least you should print the ID. I mean, I think it is better if you, because you are anyway, you have to parse the latitude and longitude. So you see in the note I have written that it has ID, latitude and longitude, and also name. So I think these 4 you should print.
All nodes don't have name.
No, but then you are searching by name, na? If it does not have name, then it will not show up in the search.
So for K closest nodes, you can search by ID.
Oh, for K closest node, acha, acha. Yeah. For K closest node, yes, if it has name, you should print name. You are right, yeah. It may not have name, yeah.
And sir, while finding the shortest path between two nodes, do we need only ID from the user, or we also need the name? The only those nodes which has name.
No. You should print all the nodes, okay? For the node which has name, you should print the name, because the name is much more descriptive. If you see the data,
My
ID,
doubt is in the third task, that in that third task, if we want to find the shortest path between the node A and node B, so do we need to ask the user about the enter the ID of the nodes A or B or the name?
okay. So you can ask the user to enter the ID.
Okay, sir.
So in that case, you have to do the checking that whether a node with that particular ID exists or not. Huh. So user can search for the name and then get the ID and then enter the ID. That is fine.
Yes, sir. Okay.
Sir,
Hello, yes.
sir, on Moodle, the deadline is given as Tuesday midnight. So
Tuesday midnight. Okay, let me just change it to before the submission. Yeah.
Can you please extend the deadline little?
Extend the deadline. I cannot send in a request then. Then we have to take a decision in TM meeting.
A request via mail or via Teams, because as you know that the last deadline was extended because of similar reasons, so that we were doing the previous assignment and most of our time went to that only.
So
Which is an issue.
you send a request in a team and ask your friends to upvote like or something, so that we know how many people actually need that.
Okay, sir, understood.
Sir, I tried to look for any documentation or tutorial for parsing, sir, but I couldn't find it, even with the help of header files.
For XML parsing?
Yes, sir.
There is this, I don't know, what have the other people used? So there is Rapid XML, I saw.
Yes, sir, that
Yes,
only
I've
yes,
used
sir.
Rapid XML.
Yeah, that is seems to be good. Okay, so if there are no more questions, then should we
Sir,
disperse?
is it possible for you to give a little description on how to use a Rapid XML, sir? I have tried, but I couldn't get a clarity on how to use.
Okay, right now, so I don't have it. So, okay, let me just give it to you here. So do you have any specific question like?
No, sir, not specific. I have tried, but couldn't get a clarity on how to use it.
The tutorial is there, right? There is a tutorial, right? 2 minutes.
There is a code, sir. For a small question, there was an example code, but I couldn't get any clarity from it.
Okay, let me just ping this. You have checked this link only, right?
Yes, sir, this one also checked.
Yeah, so in this, you see this 2-minute tutorial is there. Inside there is this accessing the DOM tree. Okay. So you can just browse the nodes using this first node and then next node. And then you can also get the attributes using next attribute like this. Use.
Okay, sir.
Okay. Yeah, so let me know if you need like more help. But it is pretty easy. So once you get the node, you can get the attribute, and you just need to pick the nodes which are of type node, here by node I mean this XML node, XML underscore, and then.
Sir, also, what's in the relation, sir? In the relation tag.
What is relation tag?
Oh, yes, sir, in the data.
Okay, let me just try to remember.
So there were 3 kinds of elements: nodes.
Sorry, I could not hear. Hello.
In the OSM file, after like 113,000 line, there are relation tags after the node and
Yeah, those you can ignore. I think you don't need to use those.
okay, sir.
Only nodes and ways. That is what I said. No, that I think in this thing I said that there are also many other types of elements, but only these two elements are of interest: node and way. Okay, Raunak Saha has also given another link for Rapid XML. You can also check that. Yeah, if you go to this next sibling, then you can get basically.
Yes, sir, this is good.
Okay, any other questions? Okay, then thank you very much.
Thank you, sir.
Thank you, sir.
Thank you. Thank you. Bye. Okay.
Thank you.